Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment where we're going to run a hypothesis test and a confidence interval for a regression. So we're still looking at the scenario, where did the money go? And the scenario is the British government regularly conducts surveys or on household spending. One such survey determined the average weekly expenditure on tobacco, which happens to be our X, so we labeled it our X, and the average weekly expenditure on alcohol, which is our Y, for households with a random sample from 10 different regions in the United Kingdom. The data table and computer printout of the regression analysis is provided below. I want to show you something real quickly here. I went ahead and entered all that data into stat edit. So the X value of the tobacco is in L1, the Y value is in L2, so that we're keeping with what we normally have. And if I go stat test and I actually run that linear regression test like we've done in class, and watch what happens. Oh, I see I have a y-intercept of 2.01814, and I see that my slope is 1.015. I see that my standard deviation of the residuals is 4.557, and I also see my r squared is 0.6092, so the 60.92%. So you can see where that information comes from. You can also see um, if I have a t statistic of 3.53 and a p-value of 0.0077. So basically, when I run that regression, I actually get the information for the computer printout. So the very first thing it asked me to do is run a test to determine whether or not the slope is significant at alpha equals 0.01. And the first thing is the null and alternative hypothesis in symbols and the null and alternative hypothesis in sentences. So here we go. In symbols, it's beta 1 equals 0, and it will always be equal 0. So it's super important that you know that it's always equal to 0, and that's continues to be the case. And beta 1 is our symbol for our slope. All right, beta 1 is a symbol for the slope, and the alternative is beta 1 does not equal 0. So the slope is 0, the slope does not equal 0. But be very careful when you write it in sentences. In sentences, it says there is no linear relationship between alcohol and um, tobacco. So, and it's basically alcohol, the amount of money, because this was pounds, alcohol in pounds. This is my Y value, and this right here is my X value. So there's no relationship between Y and X. And then the other one is there is a linear relationship. So this is no linear, and this is a linear relationship between basically our Y and our X, which is the pounds of money spent on alcohol and the pounds of money spent on tobacco. Okay. All right. The next thing it asks for is our formula. Well, our formula is very simple, B over SB. But what is B? All right. So B happens to be our slope, and this is the SE of our slope, or the standard error of our slope. So we need to look at our table. And what does our table say? Well, this right here is our slope right here. And this is our SB. So this is B, and this is standard error of the slope. Okay, so that's where that comes from. So when we plug in, we end up with 1.01528 divided by 2.8745. And once again, slope, standard error of the slope. When we divide that out, when we calculate, we ended up getting a p-value, and we come straight off the computer printout. Our p-value is 0.0077. And they asked us to test. And we look back, they said, test at an alpha equal to 0.01. Well, 77 is less than 100. So our decision is going to be to reject the null. All right. Now, a couple things that we need to talk about. Our degrees of freedom. Well, how many data points did we have? In this case, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And degrees of freedom for regression is n minus 2. So in this case, we had 10 data points. So we went 10 minus 2, and that gave us 8. And obviously, we needed to list our t statistic, which is 3.5320, because this right here is our t statistic, our t stat, and this is our p-value. So that's where that information came from. Just read it straight off the computer printout. So our decision is to reject the null. So here we go for our conclusion. Our p-value is 0.077, which is less than our alpha. I always want to go back and say this again. This part right here, that very first two sentences, comes from the decision box. All right. Our p-value is 0.077, which is less than our alpha of 0.01. We reject the null. Well, we reject, there is plenty, there is sufficient, we have enough to suggest that the true population slope results in a linear relationship between the pounds spent on alcohol and the pounds spent on tobacco. Once again, we're restating our Y and our X. Now, where did this sentence come from? All right. Well, what was our alternative hypothesis? Our alternative hypothesis is results in a linear relationship between the pounds spent on alcohol and the pounds spent on tobacco. So beginning right here, use a different color. Beginning right here at this point, that right there is just a restatement of our alternative hypothesis. So this, again, don't forget, is just our alternative hypothesis. So that's what we did. We just restated that. Okay, the next thing, create a 95% confidence interval for the slope. Well, first off, we're going to need our formula. And our formula for our slope is b plus or minus t star sb. Well, t star we're going to have to calculate, but b, that's our slope, plus or minus t star, which we have to calculate. And this is our standard error of our slope. So real quickly, we have our slope and we have our standard error of our slope. So that's we're going to need our B and our SB. That's coming straight off of the table right there. To calculate T star, well, we want a 95% confidence interval. So second vars, inverse T, parentheses, 1 minus 0.95, close parentheses, divide by 2. It's been a while since we've done that because we didn't do them for chi-squared. And degrees of freedom. Well, how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, our degrees of freedom are 10 minus 2, which is 8. And when we do that, we end up getting a T star of 2.306, which we're going to go ahead and make positive. All right. And once again, that degrees of freedom, and I just want to stress it again, is 10 minus 2. All right. And we always make it positive because we're such positive people. So when we plug in, we're plugging in our slope that comes right off our printout. All right. Plus or minus, this is our T star that we just calculated. We just calculated our T star. And then we have our standard error of our slope, which came off the computer printout. So then we need to calculate our interval. Well, we have a couple ways. All right. One is just plain old hard work. The other is from the calculator. Since I input the printout, I can go stat test linear regression T interval L1, L2, because my X's are L1, my Y's are L2, and I put in 0.95 alpha trace. And there's my interval right there. Now, what happens if we don't give you the computer printout? I mean, what happens if we don't give you the data set? We don't give you the data set, you can't do what I just did, and you're going to have to go about doing it the hard way. All right? So in this case, the hard way is 1.01528 minus 2.306 parenthesis 0.28745, and there it is, 0.35242. All right, so that gives me the lower bound. Now I'm going to calculate the upper bound. All I'm going to do is I'm going to take this and I'm going to change that minus sign to a plus. And then there's the 1.6781. So that gives me my lower and my upper bound. So what are we? Well, we are 95% confident that the true population of slopes for pounds spent on alcohol relative spent on tobacco. Once again, I can't stress it enough. This is my Y, this is my X. And I guess I should even highlight them with the colors that I've been using. This is my Y, and this is my X. And then it lies within our interval that we just calculated above. All right? Because this just went straight there. The next thing we need to do, the meaning of the confidence level. In repeated sampling, we expect this method to capture the true population slope. And by the way, I guess I should have highlighted the word slope because we're going to keep using it. True population slope, for pounds spent on alcohol, which happens to be my Y, relative to the pounds spent on tobacco, which happens to be my X. Once again, my X and my Y. All right. I hope this helps. I certainly look forward to seeing you on the next one. And thank